So now let's look at this problem. We are having a hyperbolic function. Then a hyperbolic function, what thing that you must know, always you'll be required to find the equations of asymptote, the axis of symmetry and all. So now let's briefly look at some basics that one needs to have before we do many things. So now the basics are like this. Uh, In a hyperbolic function, we know that y equal to a divided by x minus p plus q. This one is the asymptote. This one also is the asymptote. So sometimes they will say to you the equations of asymptote. The minute they say equations of asymptote, this is what they want. So for y, you just take it as it is. You say y equal to q. Then for x, it's just x equal to p, the value of p that you'll be seeing there. So the value of a dictates in which quadrant will the graph be located. If a is positive, the graph, or so to say a greater than 0, the graph will be in the first quadrant and the third quadrant. If a is less than 0, the graph will be in the second quadrant and the fourth quadrant. Then this graph as it is, it has asymptotes as it is. So they meet at a common point, these asymptotes. The graph will never touch the asymptote, but it will approach, does not touch. So we also have this line here, and we also have this line here. This is the negative gradient, and then this one is the positive gradient, x plus c. Sometimes they are called axis of symmetry. So this graph, when it's plotted, we need the intercepts. We need the intercepts when you draw this graph. Then for x-intercept, you let y to be 0. Then for y-intercept, you let your x to be 0. So let's dive into solving the problems that we are having. We'll deal with the translations of the graph afterwards. So now these are the questions that we are given here. The question says, given the function, write down the equation of the asymptotes of h. So the equation of asymptote of h, the first one will say y equal to, this is question number 12.1. The first one will just be, let me change the background here. Let me bring in a different background. Let's use this one as our background. The first one, we will have y equal to, we'll deal with y equal to 2. And then the second one, which is the value of x, will have x equal to 2. Remember, this one I told you that you need to solve for x. Now, let's go on to look at the calculation of the x-intercept. Let's look at 12.2. For x-intercept, we simply let y to be 0, then we'll have 0 equal to negative 2 divided by x minus 2 plus 2. We transpose 2 to the other side, we'll have negative 2 equal to negative 2 all divided by x minus 2. Then this is negative 2 into, negative 2 into x minus 2 all equal to negative 2. So we'll have negative 2x plus 4 equal to negative 2. Then negative 2x equal to -6. Then we divide both sides with 2, with -2. Therefore, x is equal to a positive of 3. So from this, I advise people to write it like this always: x of positive 3 and 0, because you are going to use this point when you will be plotting the graph. So from this, we are going to look at the preceding question. We are having 12.3. They are saying you need to draw the graph. Remember, to draw the graph, you also need the y-intercept. So you'll first find the y-intercept. Then how do you find the y-intercept? You'll find the y-intercept thereby let x to be 0. Then you'll have y equal to -2 divided by 0 minus 2 plus 2. This will simply give us -2 divided by -2 plus 2, which will translate to positive of 3. This is the value of y. Therefore, we can write it as a coordinate. This is 0 and 3, because we said let x to be 0. So now we have to go on and draw the graph. Né? To draw the graph, let's take note of the x-intercept that we had. We had 3 and 0. So we are going to erase this part here. We get rid of this part. Then we bring in the Cartesian plane. We try to bring in the Cartesian plane. Then, in drawing the Cartesian plane, this is the Cartesian plane that we'll be utilizing throughout this question. So, we have to indicate some axes here. We have to indicate some axes. So, this will be the y-axis. Then this will be the x-axis. The x-axis. So 1, 2, 3, 4. 1, 2, 3. Then 1, 2, 3, 4. 1, 2, 3. So if we are to draw the graph, the first thing that we need the asymptotes, which act as boundaries. So we are going to draw line x equal to 2. This is line x equal to 2 here. This is line x equal to 2. We also have another line, which is line y equal to 2. This is line y equal to 2. It will be situated here, line y equal to 2. This is our line y equal to 2. So now we check. What about the intercepts? We go on and we plug in the intercept. We have got an intercept here at 0 and 3. We also have another intercept at positive 3 and 0. Then when we draw the graph, we go back, we check the value of a. The value of a was negative. The value of a was negative. So if the value of a was negative, we will draw the graph like this. The graph should be in the second and fourth quadrant, so the graph will just be like this. This will be the graph. Another terminal arm will be in the fourth quadrant. So it's second and fourth quadrant, just like that. So now, after we have drawn our graph, we proceed to other questions, but they said we need to indicate the intercepts. This is 3 and 0. And then this side we are having 0 and 3. So this is a point of intersection of these asymptotes. This is point 2 and 2. So let's just label it P, because we are going to need it somewhere. So now the question is saying, determine the equation of axis of symmetry of H. The equation of axis of symmetry of H, they just want you to use the negative gradient. Remember, I said to you initially that when you deal with a negative gradient, we'll have y equal to negative x plus c, or we can safely say m less than 0. Sometimes when we deal with positive, it's y equal to x plus c. This is the positive gradient. They will say m greater than 0. This one is negative. Then this one is positive. Right. With that being said, we are going to draw our lines. The negative aspect will go this way, the positive aspect will go that way. So now we'll do it like this. We will utilize the one that has got a negative gradient, but when we solve these things, all those lines must pass through point P, this point here, this point P. So we'll have y equal to negative x plus c. We substitute 2 and 2, the intersection of the asymptotes. So we'll have 2 equal to negative into 2 plus c. Therefore, c is equal to 4. Therefore, we'll say y equal to negative x plus 4. That is the equation of axis of symmetry. So we are done with that question. So another question is saying, determine the range of negative h. Here we need to bring in some algebraic work because we are dealing with the translation of a graph. We are dealing with the translation of a function or a graph. So to deal with this particular problem here, we need certain aspects. What you simply do, let's quickly try to erase this question that we've just done now, so that we can quickly translate our graph. So we are having a negative h of x plus 1. So we have to shift our graph 1 unit upward. But then let's deal with this one wherein we are having a negative. So we'll have a negative, then we put everything that is on our function. It's negative 2 divided by, we divide everything with x minus 2 plus 2. That which we have done here, it will affect the numerators only. So we will end up with something like this. This is what we will end up with. So at the end of the day, we will have 2 divided by x minus 2 minus 2 plus 1. So at the end of the day, we'll have 2 divided by x minus 2 minus 1. So when they are looking for a range, we want to check for which values of y is the function defined. So in this regard, we'll say y is an element of real numbers where the value of y should not be equal to -1, because if it becomes equal to 1, this graph will not be defined. The graph that we are having here will not be defined. So we have translated our graph. Afterwards, we have shifted it 1 unit upward. Hence, we are having that which we are having here. So now, here is another question. They are saying, determine the values of x where h of x is less than 0. So we just want to check the values of x for which this graph that we are having, it lies on or below the x-axis. So we check the x-intercept. So I'll try to remove this switch that we are having here. We will have h of x less or equal to 0. You mustn't use the algebraic method because you might lose some marks somewhere. You are just going to look at the graph. We want to check wherein this graph lies on or below the x-axis. It lies on the x-axis at this particular point here, and also this one. But we need to exclude the asymptotes. We need to exclude the asymptote, because if we are to say it's wherein x is less or equal to positive root 3, you are saying for all values that are less than positive root 3. So you are including 2, but we say that the graph must not touch or cut the asymptote. So you simply do it like this. The values of x for which that graph lies on or below will be between two values. We are saying x must be less or equal to 3, but we need to restrict it. It must not touch 2. So we'll say 2 less than x less or equal to positive root 3. That's how we do it. Then you'll get your marks. That's it.